Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this comprehensive tutorial on Apache Fluo Recipes. In today's data-driven world, processing massive datasets in real time is crucial. Apache Fluo Recipes provide a high-level abstraction to build scalable, event-driven applications. Whether you're building analytics dashboards or real-time recommendation engines, these recipes simplify development while maintaining performance and consistency. Before diving into recipes, let's understand Apache Fluo. Fluo is a distributed computing framework built on Apache Accumulo. It processes large datasets by reacting to changes incrementally. Instead of recomputing entire datasets, Fluo updates only the affected parts, making it ideal for real-time systems. Apache Fluo recipes are high-level components that encapsulate common distributed computing patterns. They simplify the development of Fluo applications by reducing boilerplate and offering reusable logic for tasks like counting, exporting, and hashing. This allows developers to focus on business logic rather than infrastructure. Let's explore the core Fluo recipes. The counter recipe allows atomic counting across distributed systems. ExportQueue helps export processed data to external systems. RowHasher distributes rows evenly to avoid hotspots. CombineQueue merges values efficiently, and visibility controls access based on security labels. Each recipe solves a unique challenge in distributed data processing. Fluo recipes work by extending Fluo's core observer and loader APIs. They define structured ways to read, write, and react to data changes. When a change occurs, Fluo triggers the appropriate recipe logic, ensuring that updates are processed consistently and efficiently across all nodes in the cluster. Let's start with the counter recipe. It provides atomic increment and decrement operations across a distributed system. This is perfect for tracking metrics like page views or user actions. The recipe handles concurrency and scaling automatically, ensuring consistency even under heavy load. The ExportQueue recipe helps export processed data to external systems like Kafka or databases. It guarantees at least once delivery and supports batching and retries. This makes it a reliable bridge between Fluo and other data systems in your pipeline. RowHasher addresses a common issue in distributed systems: data hotspots. By hashing row IDs, it ensures an even distribution of data across nodes. This improves performance and scalability, especially in large datasets where certain keys might otherwise be overrepresented. CombineQueue allows you to combine values efficiently using associative operations like sum or max. It reduces network overhead by combining data before sending it across nodes. This is ideal for real-time aggregations where performance is critical. The visibility recipe controls access to data using security labels. It integrates with Apache Accumulo's built-in authorization model, ensuring that only authorized users can access sensitive data. This is essential for applications that must comply with privacy regulations. The architecture of Fluo recipes is built on top of Fluo's observers and loaders. These components react to changes in key-value pairs stored in Accumulo. Recipes define structured patterns for reading, writing, and reacting to these changes, enabling scalable reactive updates. At the core of Fluo are observers and loaders. Observers react to changes in data, while loaders initialize or seed data. Recipes extend these APIs to provide reusable modular logic. This makes applications easier to test, maintain, and scale. Fluo recipes rely on structured key-value design patterns. Keys are organized into column families that represent different aspects of the logic. This enables scalable data modeling and supports features like versioning and timestamps, essential for real-time systems. Unlike traditional batch systems that recompute everything periodically, Fluo recipes enable incremental updates in real time. They react to events as they happen, making them more efficient and scalable. This is especially important for systems that require low-latency responses. Let's look at a real-world use case, a live analytics dashboard. Using the counter recipe, it tracks metrics like user activity. The ExportQueue recipe sends processed data to a visualization engine. Together, they provide real-time updates without lag, scaling effortlessly with data volume. Another powerful use case is a dynamic search index. Instead of reindexing everything, Fluo Recipes update only the changed documents. RowHasher ensures even distribution, improving query performance and reducing system load. Social media platforms use Fluo Recipes to update user feeds in real time. CombineQueue aggregates likes, comments, and shares efficiently. This ensures low latency delivery even when handling millions of concurrent users. In IoT systems, Fluo Recipes analyze sensor data in real time. Counter tracks anomalies, and ExportQueue sends alerts to monitoring systems. This approach is scalable, fault-tolerant, and ideal for mission-critical applications. Fluo Recipes offer significant performance benefits. By enabling incremental updates, they reduce system load. Recipes optimize common tasks like counting and exporting and scale effortlessly across clusters. This results in low-latency processing essential for real-time applications. Fluo Recipes are inherently scalable and fault-tolerant. Built on Apache Accumulo, they handle node failures gracefully. Recipes ensure data consistency and include automatic recovery mechanisms, making them reliable for production systems. Security is critical in distributed systems. The visibility recipe provides fine-grained access control by integrating with Accumulo's authorization model. It supports role-based permissions and ensures compliance with data privacy regulations. Fluo Recipes integrate seamlessly with systems like Kafka and Spark. ExportQueue can send data to Kafka topics, while Recipes can trigger Spark jobs for deeper analysis. This enables hybrid architectures that support both batch and stream processing. To get started with Fluo Recipes, you'll need a Hadoop and Accumulo cluster. Install the Fluo distribution, configure cluster settings, and test with sample recipes. This setup lays the foundation for building scalable, real-time applications. Writing your first Fluo recipe is straightforward. Extend the observer or loader class, define your key-value logic, and use Fluo's transaction API to ensure consistency. Test your recipe using Mini-Fluo for local development. Testing Fluo recipes is made easy with Mini-Fluo, a lightweight testing framework. You can mock observers and loaders, validate key-value interactions, and simulate distributed scenarios locally. This ensures your recipes work correctly before deploying to a cluster. Debugging and monitoring are essential for production systems. Fluo provides a web UI for metrics, logs for observer and loader events, and tools to monitor transaction performance. You can also track the status of export queues to ensure data is flowing correctly. To get the most out of Fluo recipes, follow best practices. Keep observers lightweight to reduce latency. Use batching for efficiency, avoid long-running transactions, and always test your recipes under load to ensure performance and reliability. Common pitfalls include overcomplicating key structures, ignoring transaction timeouts, and not handling failures gracefully. Always design for simplicity, set appropriate timeouts, and test thoroughly to avoid these issues. Let's take a deeper look at CombineQueue. This recipe efficiently aggregates values using custom combiners. It reduces network traffic and is ideal for real-time analytics where performance is critical. You can define your own combiner logic to suit specific use cases. Visibility is a powerful recipe for controlling data access. It supports multi-level permissions and integrates with external auth systems. This ensures regulatory compliance and protects sensitive data in distributed environments. Fluo recipes are part of the broader Apache ecosystem. They integrate with Hadoop, Spark, Kafka, and Flink, making them a versatile component in enterprise data platforms. Whether you're building real-time dashboards or IoT systems, Fluo recipes provide the foundation for scalable, reactive processing. Compared to alternatives, Fluo recipes offer unique advantages. They're more efficient than full recomputation, easier than raw Fluo APIs, and have less overhead than Spark streaming. They also provide better consistency than Kafka streams for certain use cases. To continue learning, explore the official Apache Fluo documentation, GitHub examples, and community forums. There are also hands-on workshops and courses available to help you master Fluo recipes and build real-world applications. The future of Fluo recipes looks promising. The roadmap includes improved documentation, new recipes for machine learning, better cloud integration, and enhanced performance monitoring tools. These developments will make Fluo even more powerful and accessible. The Apache Fluo community is active and welcoming. You can contribute recipes, improvements, and documentation. Join mailing lists, attend conferences, and participate in meetups to stay updated and connect with other developers. In summary, Apache Fluo recipes simplify distributed computing by providing reusable components for common patterns. They enable real-time, scalable applications and integrate seamlessly with the broader data ecosystem. Whether you're building analytics dashboards or IoT systems, Fluo recipes are a powerful tool to have in your arsenal. Thanks for watching this deep dive into Apache Fluo recipes. If you found this tutorial helpful, please like, subscribe, and leave a comment with your questions or use cases. Explore more tutorials on our channel, join the Fluo community, and start building something amazing with Fluo recipes today. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.